Now we're going to look at exponential growth and decay formulas that we can use to solve some real-world type problems. So the formula for exponential growth is going to be y equals a, and I'll explain what these letters all mean in a second, and then in parentheses 1 plus r to the, sometimes you see a t here, sometimes you see an x. Our book uses x, so I'm going to use x for right now, but that's also sometimes t, and that's perfectly correct. Okay, so for both exponential growth and decay, the a means initial amount. So what do you start with? The r is the rate as a decimal. So it's almost always going to give you the rate as a percent. We need to turn that percent into a decimal. If you need to remember how to do that, to turn a percent into a decimal, you move the decimal 2 places. Move the decimal 2 places to the left. So for example, if we have 16%, move the decimal 2 places, and that's 0.16. Another example, if we have 3.5%, move the decimal 2 places, and that's 0.035. And that's because we'll have to put a 0 for that placeholder in here. So 2 places to the left. All right. And then the x equals, not really years. Sometimes it's years. It's not always years. So the x equals the time. How long is this going to be happening for? Then exponential decay is very similar, except it's 1 minus the rate. All right, and then the compound interest formula, this one looks a little bit different. Y equals P, and P is the same thing as A. It's the initial amount. So that's the initial amount or starting amount, right? Whatever makes sense to you. And then 1 plus, because if you're talking about compound interest or you're earning interest, means it's going up, so it's always going to be growth. So it's 1 plus. This time you're going to take the R and you're going to divide that by N, and so R equals the rate again, and always turn that into a decimal, but N equals the number of times it's compounded per year. So if it says that your interest is being compounded yearly, that means 1 time per year. So you would use N as 1. If it says it's being compounded monthly, well, there's 12 months in a year. That means it's being compounded 12 times. So your N would be 12. And then the exponent on this is going to be N times T. So again, N is the same N for both. T is the time. So how many years? All right, so let's go look at some examples of how we can use these formulas to help us solve some real-world problems. Okay, so write an exponential function to model the situation. We're going to do 2 things. We're going to do that. We're going to write the exponential function first, then we're going to answer the question. And I believe on your quiz or test, it'll actually be separated into 2 parts. Here's a space for your model, and here's a space for your answering the question. So like this, how many bacteria will be there in 6 hours? That's the second part of it, so we'll do that second. Okay, so a bacteria culture starts with 500 bacteria. There's our initial amount, that's our A. The number of bacteria increases. Increases tells me that this is going to be a growth model. And then 8%, so 8%, that is, move the decimal 2 times. So 0.08. Okay, so since it is growth, that's going to be y equals our amount, 1 plus the rate to the x. So then we want y equals, our A, our initial amount is 500. 1 plus, our rate we found was 0.08 to the x. So notice I'm ignoring the 6 hours. How many bacteria will be there after 6 hours? So that's the answering the question part. So I'm going to save this answering the question part for after we finish our writing our model. So we're always going to write our model first, then we'll go back and answer that question. So I'm almost done writing my model, but I can simplify this. You always have to simplify to get all your points. I can do 1 plus 0.08 is 1.08 to the x. So this is the model completely simplified. Once we have that model completely simplified, now we're going to go back and answer the question, how many bacteria after 6 hours? So I'm going to take that model, y equals 500 times 1.08 to the, I'm going to replace the x now with 6, because I want to know after 6 hours. And I should make sure this matches. This is talking about is going up each hour in hours. The times have to match. If they don't, we would have to make some conversions, but I don't think we have to get into that for this lesson. And then once we have this model written out with our 6 in the exponent spot, you can just put this in the calculator just like this. Make sure you put that 1.08 in parentheses and use your caret 6. And then that is going to give us 793.44, and we're talking about bacteria, so that much bacteria. You do not have to write these real-world problems as fractions. It makes more sense to leave them as decimals. And in fact, if you tried to write most of these as fractions, they're either not going to be because they're irrational numbers, or it's going to be a really crazy fraction. So we'll leave these as decimals, but make sure you're rounding properly. A phone is purchased for $900. Its value decreases. Since it tells us it's decreasing, that means it's going to be a decay problem. So then I'm going to write my problem out, my model out. That's going to be this, the 1 minus r, 15%. So 15%, move the decimal 2 times. That's going to be 0.15. And then we'll save this 4 years for after we write our model. So y equals, our initial amount was 900. 1 minus, our rate we found was 0.15 as a decimal, to the x. Again, don't put that 4 in there until we're ready to solve. And then we have to simplify our model. So 1 minus 0.15 is 0.85 to the x. So this is going to get you your full points for writing your model and having it simplified. So once we've got that model and it's all simplified, now I can plug in, I want to know what will that phone be worth after 4 years. So we have y equals that 900, 0.85, but instead of to the x, it's now going to be to the 4, because we want 4 years. And then again, plug that in the calculator just like it is. Make sure you have those parentheses with the 4 on the outside of parentheses. And we should get, this is talking about how much money is it worth, so it's dollars. $469.81. And again, make sure you're rounding properly. Okay. Number 12. A patient is given 80 milligrams of medication. Each hour, 20%. So 20%, move the decimal 2 places. So that's going to be 0.2 or 0.20. Those are the same thing. 20% of the medication leaves the body. If it's leaving the body, it's decreasing. So again, this is going to be a decay problem. So then I'm going to set up my model. 1 minus, since it's decay. And then I'm going to start filling in everything. So my initial amount is 80 milligrams of medication. 1 minus, our rate we found was 0.2 or 0.20 to the x. Again, yes, it says 5, but we're ignoring this until we're ready to solve. So we get y equals, make sure we simplify this. So 1 minus 0.2 is 0.8 to the x. So here is our fully simplified to get all our points in model. Now that I have my model, I'm going to plug in the 5 hours. So y equals 80 0.8 to the 5, and then put that in the calculator, and that's going to give us 26.21 milligrams. So now we're talking about, we see this as compounded annually, compounded monthly. So we're talking about compound interest now, and down here compounded quarterly. So for these last three, we're going to use that compound interest formula. So that was, I'm going to write over here so we can see it on the same screen. Okay. So P is our initial amount. So Y equals, our initial amount this time is 1,200. 1 plus, now we need our rate. Our rate is 4.5%. Move that decimal 2 times. Fill in those zeros. So that's 0.045. 0.045 is my rate, divided by n. Remember, n is how many times it's being compounded. So it says it's being compounded annually. Annually means yearly, so just once per year, so that's divided by 1. And then again, n here is 1. And then, again, it says 10 years, but we got to pretend we don't know that yet. We leave our t there until we simplify this model. So y equals 1,200. And then we can just put this in our calculator. But if you do that, you need to put parentheses around this 0.45 to the 1, or use your fraction button. Otherwise, it's going to add the 1 first before it divides. So be careful how you put this in your calculator. You should get 1.045. What I sometimes like to do, to make sure I don't make an error on my calculator, I'll put this part in my calculator first, and then I'll do the plus 1 after that. So make sure you get this value. And then 1 times t out here, this 1 times t is just t. So I'm going to simplify that and say just t. So there's my simplified model. Now I'm going to answer the question, is how much money will be left after 10 years? So now I'm going to substitute in 10 for the t. So y equals 1,200, 1.045 to the 10. Put that in the calculator. And we're talking about the amount of money. And you put $1,200 in, and after 10 years, you now have $1,863.56. Number 14. Y equals our initial amount, 2,500. 1 plus our rate is 6%. Move that decimal 2 times. So that's going to be 0.06. It says it's compounded monthly. And because we're talking about in a year, so there's 12 months in a year, so our n is 12 here, and the n is 12 here, and then times t. Remember, there's 2 n's. N goes here and here, in the denominator and the exponent. And then we need to simplify our model before I can solve. If you put this part in the calculator correctly, we should get 1.005, and then we'll just leave that as 12t. So there's our simplified model. There's our first point. And now we can answer how much after 8 years. Keep the whole thing the same, except instead of 12t is now 12 times 8. And then we're going to pop that in the calculator. However, with the exponent, you either have to put the exponent in parentheses or multiply the 12 times 8 first and put that answer as your exponent. So then you should get, for your answer, again, we're talking about money, $4,035.36. And for the last one, our initial amount is the 5,000. 1 plus our rate is 3.2%. Move that decimal 2 times. So that's going to be 0.032. 0.032. And then this one says compounded quarterly. Quarterly means 4 times a year. Think like there's 4 quarters in a dollar. So 4 there, 4 here with your t. Now let's simplify the model to get all our points for our model. If you put that in the calculator correctly, you're going to get 1.008 to the 4t. And now we can plug in our 6 years. So we get everything stays the same, except for now it's going to be 4 times 6. And again, you're either going to put this in parentheses, the exponent in parentheses, or 4 times 6 and put in 24 as your exponent. And then if you solve that properly, again, we're talking about money, we get $6,053.73. And make sure you're rounding all these properly. So that's how we do compound interest. And just make sure you're reading carefully. Monthly is 12. Quarterly is 4 times. If it says annually, that means you're doing it 1 time per year.